All right, factor by grouping. So this is a specialized factoring strategy that helps us to identify binomial factors in expressions containing 4 terms. So this is important. But one thing, if we're going to try and factor this expression, we see that there's 4 terms. And in the terms, I just want you to notice that there's no greatest common factor. Basically, no monomial factor that's common. So there's nothing common. There's no n's, 3, 2, 9. So what we're going to do is we're going to group these terms together. Instead of all 4 separately, we're going to kind of look at this as the first 2 terms. We're going to group these 2 terms together and look at those, and then we'll group these 2 terms together and look at those. So is there common factors in the first 2 terms? And yeah, there is a greatest common factor between 3n cubed and 2n squared, and that's n squared. And what's left would be a factor of 3n and then plus 2. If we look at the other grouping on the other side, and we look at that separately, is there a common factor? And yeah, so there's a common factor of 3. So we have a common factor of 3. Whoops, there it went. And what's left of the 2 terms when I factor out a common factor of 3? And it would be 3n plus 2. So now we have to realize that we are looking at the expression, but we just basically looked at the 2 expressions, or the 4 expressions, as 2 groups. So now we'll notice after we do that, notice now we have a common binomial factor. So the 2 terms now have this common binomial factor of 3n plus 2. So if we factor that common binomial factor out of these 2 terms, we would have this 3n plus 2, and what's left, or what do we need to distribute to get the 2 terms back? So 3n plus 2 times n squared, our first term here would be n squared, and if I distribute over here, you notice I would have to distribute to a plus 3 to get that term. So this factor by grouping allows us now to write this whole expression in factored form. So we're basically looking for binomial factors. So we group 2 terms, look at the binomial factor that those 2 terms have, and the other 2 terms has the same binomial factor. So if that happens, we can factor again the binomial factor of 3n plus 2 out. So let's try that again with the next expression. And again, the first thing we're going to do is we notice in this case there is a greatest common factor. So we do have a greatest common factor of all the terms. So we notice that there's a 3 that's common to all the terms. So if I take the 3 and then rewrite my 4 terms as a distribution, I would end up with x cubed minus 2x squared plus 5x and then minus 10. So we do have a greatest common factor, so we'll do that first. But now we want to try and look for binomial factors. So our factor here has 4 terms. This is a grouped factor that has those 4 terms. So maybe we can look for um, binomial factors in that. So again, for the process, we're going to take and look at and group the first two terms together. They have a common factor of x squared. And what's left, if I factor out an x squared, would be x minus 2. The next grouping, the next two terms, if I look at those, has a common factor of 5. And what's left is an x minus 2. So again, this is plus between those two terms. Okay, so the x minus 2 common factor, we have a common binomial factor. So now we're going to take that and factor out the x minus 2, and what would be left from our two terms would be this x squared from this term, and then the plus 5 from this term. So remember, right away from the beginning, we don't want to forget that monomial factor of 3. So this 3 is also a factor of our original polynomial, and then we factored by grouping the grouped factor. So we could check this by multiplying it out, but okay, let's try the one last example here. So we have 4 terms, and there's no common factor, so there's no common monomial factor, greatest common factor. So there is 4 terms, so we do have the 4 terms, and that's our key to this. We need 4 terms so that we can group and look for binomial factors. So the grouping, I'm going to take and look at the first 2 terms, and they have a common factor of b, and what's left would be a b minus c. So if you distribute back, you would get b squared minus bc. The second grouping, there's no common factor, but again, it starts with a negative factor. So if it starts with a negative factor, we are going to factor out a negative 1 from the 2 terms. And if we think about just factoring out a negative 1, what would be left? Well, it would be negative 1 times, well, I would have to multiply the first term by b, and then negative 1 times, I'd have to have negative c to get positive c back. So there is common binomial factors. So factoring by grouping will work, and if I take out that common binomial factor of b minus c, and what will I be left with? Well, from this term, I'll be left with that b, and from this term, I'm left with that negative 1. So b is left from the first term, and then if I distribute, I would have to have a negative 1 here. And that's factor by grouping. So it's 2 steps. Factor or group the terms together and look for binomial factors. If they're common, then you can continue to factor. Will it always work? No. But if it does, this is the method to do it. Sorry. All right. Till next time.